The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
The METUS Tech Show.
So, Andrew, you've been talking about sous vide. I've never heard of it. It's spelt a whole lot differently than it sounds. What the heck is sous vide?
Yeah, Paul. Well, you're right. It's spelled like sous vide, like you said earlier today, and it's, I believe, French. So kind of say it however you want, because I live in what you call Versailles, Kentucky, but we call it Versailles here. If you call it Versailles, you'll get run out of town. So, it's to each their own on how they want to pronounce it. But yes, it's sous vide, and it's a method of cooking. You can cook any, a big variety of foods from meats to vegetables. Personally, I only use this for steak. So I have the required, hardware to be able to do this for a steak application. And, previous to this, I was a big reverse sear guy. So in other words, you're starting out with searing your meat, and then you are bringing it up to temp slowly afterward, whether in the oven or on a low temp, a smoker of some kind, and bringing it up to exactly where you want it to be. It's a great method. However, I have fallen in love with the sous vide method. And what it is essentially is it's sealing your protein in a bag, a vacuum seal bag, and you are putting it into a water vessel of some kind, whether it's a pot, whether it's a purpose-built vessel for sous vide specifically, and then some type of immersion circulator with heating element. And what this allows you to do, before people jump to conclusions and things, so you're boiling your steak in a bag. You're not boiling anything. You're actually bringing up and setting the environment to the precise temperature of that steak that you want it to precisely be. So where I'm a medium rare guy, I want my steaks between 126, 128 degrees Fahrenheit internal temp. So what I can do is have these steaks. Now, again, this method works with thick cut steaks. This is when you really want to go all out. You get your 1.5 to 2 inch cuts from the butcher. That's where this really shines. And it's really hard to perfect, a reverse sear with a meat, a cut this thick. Because in a perfect world, in my eyes, what I want is to have a nice crust, a nice sear, and then I want edge to edge medium rare or medium or whatever it is that your preference is. I don't want layers like, the layers of the earth, right? I don't want, sear and then dark gray and then light pink and then, medium rare in the very center. So what the sous vide does is it creates in my case, 126 degree water environment of circulating water. And then I can bring this steak up to that temperature, about 40 minutes per inch of meat. And in about an hour and a half, I can pretty much set that and forget it, right? And then meanwhile, personally, I'm a big green egg guy. So I have a Kamado style grill, smoker, cooker outside that I'll simultaneously get fired up. And the green egg can, no sweat, go 700, 900 degrees Fahrenheit. So I'll get a cast iron skillet in there with a fire roaring, and I'll get it up to well over 700 degrees.
Wow.
So when I hit that time mark, pull your bag out of the water, your steak is exactly 126 degrees completely through. You cut your bag open, blot it dry if you'd like, do whatever you want seasoning wise. For me, it's just a coarse sea salt. And then it goes right onto that egg for about 40, 50 seconds per side. And I'll tell you what, you can't. I don't know. I haven't seen it yet. Something that's topped it. It's really ruined. It's ruined steak for me abroad. At a restaurant. When I go on the road now, I hardly ever actually order steak.
No, because when you get a steak at a steakhouse and you order it rare, they say, warm pink center, or medium, whatever. It's a pink center. It's only the center is the way you want it. Like you said, the outside of it could be well, and the inside. The center of it is going to be rare or medium or wherever you like it. So I've never heard of it. I have to give this a shot.
Yeah, it's an art.
Yeah. It is. And the beauty is if you've got a good connection with a local butcher and you get a little bit of a deal per pound, based on bulk, if you buy a rib roast and you have them cut it into, 2-inch steaks, you can pre-vacuum seal these at home. If you're somebody that likes to play around making your own, herb butters or anything like that, you throw a big knob of that into the bag, seal it up. It goes in the freezer. And the sous vide, it works exactly the same directly from frozen. So you can throw a frozen 2-inch steak right into the water, and you're good to go at any point. So that's really. Now,
Andrew, are you using like an Instapot for the boiling, or not the boiling, but the cooking of the initial cooking of the steak? I don't know if you know what I'm talking about, those Instapot probes or.
Yeah, I have an Instapot. I've never used it for sous vide, but you can go as low tech as just a stainless, or I guess aluminum, just stock pot.
Yep.
And finding a way to mount that little immersion tool onto the side. They usually have some kind of a clip on it anyway. And you could go as low tech as, you could do Ziploc bags. I don't really recommend it. You'd want to kind of have the bag open and dip it into the hot water so it kind of seals the bag as you dip it, and then right at the last minute seal it. And then you still want to find a way to kind of keep the zipper part above the water, because it does get in. Or as high end as, and I say high end, it was maybe $150, but a purpose built basin with a sealing lid to prevent any heat, minimize heat loss, and then like kind of an opening for that immersion heater to go right in.
No, I apologize if I missed it, but how are you monitoring the temperature of that steak?
It's programmable. So, in this case, I have one that's Bluetooth, and I put all my parameters in. So I give it a set point, and it has a coil style heating element, and then it also has an impeller. So it heats up the water to the temperature that you've programmed it, and then it also is circulating that water to keep it agitated, to keep it moving around the meat.
So I like medium. So I like it medium. So the water's going to be about 135 degrees. So you set it and forget it. That water's at 135.
You don't have to worry about overcooking the.
No, because 135. Once it reaches,
that's 100, the thing.
That's the temperature. It doesn't.
That's pretty cool.
Doesn't increase in temperature.
That's pretty cool.
You could even forget about it and go do errands. And I said about say it's 40 minutes per inch of meat. You may go out for 4 hours and come back, and that meat's going to be medium. It won't be a tad more well done than that. It can't be.
It's got to be good. It's got to be good because I'm pretty sure the French know a thing or two about cooking.
Yes.
Anyway, thank you, Andrew. That was very enlightening. And welcome, everybody, to the METUS Tech Show. My name is Paul Schaubs. Joining me in studio is Steve Pimentel.
Hey, how you doing?
And Bryn Raptor. Bryn, say hi.
Hello.
Hi. Joining us remotely is Ralph Wolf. Ralph, you've been quiet so far. Are you on there?
I'm just kind of listening to what Andrew had to say.
All right. Now, Ralph, before we introduce Andrew, I heard a good rumor about you that you've actually gained a few pounds.
Yeah. I have to buy all new jeans. My top button doesn't button anymore. I went out to the last.
And this is why we invited you.
Belt.
This is why we invited you on the show.
You said 30 pounds.
No, but not quite 30. Yeah. But you're getting this, so we're giving you a little taste of it, so you can, as an incentive, to gain a little more. Thanks, Ralph. Yeah. And we have a special guest today, Andrew. Andrew, go ahead. Tell us who you are, who you work for, and what you do.
Yeah, well, real quick. First of all, for Ralph, if you were listening to what I was, you could always swap the steaks out, and you could do spaghetti squash. You could do, eggplant. You could sous vide anything that you need. So if if you're trying to lose any weight, there's a lot of applications there.
He's trying to.
I won't be eating any eggplant squash or anything.
Oh, me neither. Me neither. I'm Andrew Greaves. Really appreciate you all having me on today. I am the director of user experience at NAVAC Tools. That really is a couple hats at NAVAC. I run the training department. I write the curriculums for the training, traveling trainers, training manager. And then I also play a big part with product as well. So the way that we kind of do things at NAVAC is we have a product team, a product director that is the interface between NAVAC and the factory. And then what I play a big role in is from the ground level, the contractor level, to the NAVAC product team. So that's kind of our chain of maintaining our thumb on the pulse of the end user and making sure that kind of makes its way to the factory.
All right. So NAVAC is makes tools for our industry, and that's where I'd like to start. Let's go over some of the tools that an HVAC technician really, I'm going to say he shouldn't live without, but I'd like to say he can't live without. So let's go over it. So what doesn't have to be in any particular order of importance or anything, but let's just go through some of the tools that you guys have.
Sure. Well, and NAVAC is an international brand that is the largest manufacturer of vacuum pumps in the world, as well as recovery machines. So, those would be, in my eyes, kind of the flagship tools or products that you would probably find in every single technician's vehicles if they handle refrigerant of any kind. However, there's a couple other categories of tools that you'll typically see in every, technician's arsenal. So you've got recovery, you've got evacuation tools, you have refrigerant tools, whether that's your manifolds, your hoses, your valve core removal tools, these types of things, leak detectors. Okay. And then you've got your instruments. So if you're doing any kind of measurements of the air around you, which hopefully you are, you've got some types of tools to be able to measure airflow, temperature, relative humidity. On top of that, you're probably going to have some type of fittings with you, whether they're removable, whether they're permanent. That's another thing that we are involved in at this point, is many different types of fittings to kind of be the bits and pieces that go between all the tools, connecting tools to the HVAC equipment.
All right. So let's take a technician in the truck and let's talk heat pump install. So let's take the installation. I'm installing a heat pump. What is a tool that I should not be living without? And what is a tool I should have in my truck readily available and use it every day I go to install a heat pump?
Well, the first thing that comes to mind for me is, having the tools that are going to ensure that, assuming that we're going to be running a line set. Yep. And frankly, even if it is an existing line set, we want to have really great discipline with our installation in terms of piping, not only making sure that we're following all the manufacturer's specs on running the line sets and the design, but we want to keep that tubing clean. Because when we perform our evacuation, which to me is the most critical part of that commissioning and startup of a heat pump, we need to be able to start at the best baseline that we can. And that comes down to the technician's discipline throughout that installation, whether they're using nitrogen, they're doing a good job raising, if they're leaving the job site overnight, that they're sealing things off, hopefully under a light nitrogen charge. And from there, that vacuum pump is going to be able to do the best job that it can, which is to void that system of any moisture or non-condensables, which will allow that equipment to perform as advertised.
I think one of the biggest challenges in our industry is a couple. I've been doing this for a few decades, and we have a lot of bad habits in the industry that get passed down from old-timer to an apprentice, and then the apprentice becomes an old timer and passes those down. But I want to talk about flaring and flaring tools. The first question I have for you: is there a difference between an R22 flaring tool and a 410A flaring tool? Because that's a big debate out there.
Well, yes, that's something that's been out there a long time. From my standpoint, from our standpoint, NAVAC standpoint, and the training that we give, the confusion comes from, I think, the angle of the flare. So to me, the reality is a 45-degree flare is the angle of flare that you're going to see on a 410 installation and an R22 installation. It's not so much the angle, which I hear that a lot, that it was a different angle. And I think that confusion comes from the 38-degree angle, which is actually the most widely used angle in the world. Internationally, the 38-degree flare is much more popular. And then you could go even further and say the double flares and bubble flare. There's, those are actually more common as well, for many reasons. They're typically used in hydraulics and things that need a much higher rating, which we're talking over 5,000 psi. We call low pressure flare, which is what we use in the industry, is under 5,000 psi. And if you think of a 38-degree flare, the reason it has more grabbing power is if you think, and this may be difficult for a listener, but if you picture your hand being held up in the air, opened up almost like a flare, and you're going to grab a baseball, you're going to have a tighter angle and you're going to have a much better grip of that baseball than if you have to open your hand up further and palm a beach ball. A much wider flare, you can grab it, but somebody's probably going to be able to pop that out of your hand a lot easier than if you have your tighter grip on a baseball, which would be that tighter 38-degree angle. So that's the first thing, is that the angle's the same. What it comes down to more is the strength of the flare, the strength of the copper that's needed for 410. It needs to be more resistant to higher pressures and things of that nature. We want to have an orbital action in our flaring tools. And that's much more what we're concerned with than the angle of the flare itself. And there's just less room for error in the flare with a 410 flare. So it's just more important that and critical that we're checking these flares and that they're passing a consistent test of quality in order to perform as designed under the higher pressures of 410A.
So the flaring tools that you guys have right now, are they the same angle as the flare? Are they a 45-degree angle tool?
They're all 45-degree. They're all orbital in design in terms of the action. And we do have 3 different tools depending on budget and frequency. So, if the technician has a budgetary leaning in their preference when they're choosing tools, we have your bare bones manual flaring block. However, in keeping with that understanding of how critical a 45-degree flare is on a 410 system, it has that clutch to be able to pop out and not allow that technician to overflare it as easily. We have that same version with a handle that's removable so that it can be used with a drill, whatever drill that you already carry. And then, of course, we do have the Cadillac, which is that battery-operated flaring tool for people that both are understanding the value proposition with a tool like that if they're doing flares every day. So if these are your Mitsubishi contractors, your diamond dealers, people that are doing these installations on a daily, weekly basis, that tool pays itself many times over within a single season.
And I tell my contractors that come to class all the time, with the battery-operated flaring tool, to me, it's a no-brainer because it's cutting down the amount of errors you're going to make when making the flare, and you're making consistently good flares one after another with the battery operated. It just, like I said, the gauges, everything is built into that tool, and you're just that's key when making flares, is to make consistently good flares. You got 5 flares to make; they should all look identical, and I think that tool really does that.
Well, and we have so many of those kind of redundancies built in to ensure that, right? Whether it's, the tools themselves do have those depth gauges to ensure that the tubing is not over-inserted or under-inserted into the block, which makes a huge difference. We've got some great, which I owe you guys a few photos and images and slides, but the differences between a flare that's even slightly under prepared or over prepared is huge. And that's on the setup end, but then on the post flare end, we do have a great flare gauge with a barely visible little machined rim inside the gauge. Each hole for each size tubing or each size flare, it's got to pass through that gauge halfway. And it's got to hit and sit on that little tiny machined ridge. There's the tolerances are almost, you couldn't do this with the naked eye. If you under flare it, it's going to pass all the way through the gauge. If you over flare it, it's not going to even enter the gauge. And you could have all three. You could have one that's barely under, barely over, and perfect. And to the naked eye, they'd all look like, what many people consider their perfect flares.
Right.
Yeah, I actually do an exercise in class with actually a flare gauge, and it's the same thing. I have 3 flares. They all look good visually, but only one actually passes that flare gauge test that gets caught on that ridge. And just to show how important something like that tool is, they may all look great. They may look like perfectly fine flares, but unless you're using tools to verify your work, you could be putting on an improper flare.
Yeah, I was taught in the beginning in HVAC school a long time ago. Carry a nickel with you, and you stick the pipe up through the flaring block, the thickness of the nickel. Yeah. And then, but your tool, you said it has a stopper, so you stick the pipe in only as far as you need it. It does it for you.
Yeah, there's depending on the tool that you have, there's either a slider that runs across the entire bar with your manual block. So no matter what size you're using, you slide this across at the end, and you should have your tubing, just barely mate up with that. And then on the battery operated, each clamp has a swivel style little flat piece that slides over the tubing. And then you slide that over, and then you just press your tubing up against it, and you're ready to go.
Do any of those tools that you have automatically deburr the pipe, or is that a whole process you got to do before flaring? They
don't automatically deburr. I will say, however, to not overlook that step. So it is a critical step. If you've got too much material, too much of a burr that you've left behind, it's going to make an impact. It's absolutely going to make an impact. If you over deburr, it's going to make a big impact. It's almost just as detrimental as too much. I'd almost rather have too much of a burr than removing too much material, because you're almost certainly going to have cracking and fissures in that flare face when you're done. And that's a lot more likely to lead to a premature leak.
And that's where it's so important to have a sharp tubing cutter wheel.
Yes.
Right.
And that's what it is.
I've seen guys use
pinching it.
They're just rolling over the edge of the flare and of the tubing. And that's just it just makes it even harder to prep the pipe. So having a sharp cutter.
I'd go so far as to say we have a new copper tubing course from NAVAC's curriculum, and in that course, I tell people that I would tell you to skip deburring before I would tell you to deburr in a situation that you can't remove the shavings. So that's another huge aspect here. So and again, if we bring this back to Mitsubishi, heavy use of EEVs, small filters, small screens, those shavings cause so much havoc and chaos that I would say, if you don't have the means to angle that tubing downward, or whatever else your method is, sweeping a little bit of nitrogen while you're doing this, that's great. Sounds unlikely that a lot of people are going to do that in practice. But if you can't angle that tubing down at least and shake all that out, I would actually have somebody skip the deburring altogether, rather than get that garbage in the system. I agree with
you. We had a podcast on that, I don't know, months and months ago, about keeping it tight and clean, because we've seen a lot. It's like a best practice, which is really a requirement that people have just let fall by the wayside. We've had a lot of issues where we see debris in the system. We see sand and pebbles, and I've mentioned this before on a few podcasts. I've been on a roof with a roughed-in refrigerant line sticking up through the roof with a piece of electrical tape on the end of it. It's a big problem. But getting back to your flaring tool, what you guys speak to your designers. If you could invent a flaring tool that wouldn't flare unless you had the flare nut on the pipe already, I think that would be huge.
That's a fabulous idea. Yeah, we've got dozens of engineers on the factory side, so maybe something to bring up.
Yeah,
I love it.
Because I don't care how long you've been in this business. I guarantee you've done that. You've made a flare and forgot to put the flare nut. And for me, it was when I made a perfect flare. Remember this one specific time, the flare was perfect. It couldn't have been any better. No flare nut.
And you have no room to cut.
No room to
off.
cut.
Yeah,
it was a perfect.
Yeah.
All right. So
we had that in mind with our tubing cutter. So the tubing cutter has 2 grooves in it. Yep. There you go. Ralph's got one right there. And we had the flare nut in mind, right? So we know that there are times when, say you're doing a wall mounted unit and you're up there on your ladder and you don't have a lot of copper stubbed out. You sure enough, you flare it, you're ready to tie it into the unit and you realize you didn't put the nut on. You can't afford to cut off 1.5 inches maybe in this situation, up, 1.5 inches, 2 inches, maybe even. So the way that our cutter is designed is to really allow you to literally just cut the flare off. Nice. There's no waste, and it really allows you to hang on to every little bit of that length that you've got coming out of the wall to try to get in the right way with the nut on. So,
all right. So let's
can always
go ahead, Ralph.
You can always, when I do flare demos, I always have like 6-inch pipe. I have a bunch of them in a box, and I bring guys up all the time. And you can always tell where I've been because I leave little trails of the ends to flare because I use that little thing on the wheel to just put the flare in. So I have a little 1/4-inch piece of pipe. They're all over the parking lot.
Beautiful. Thanks, so littering. Okay, we'll edit that part out. All right.
Just let me know where you are so I can scrap it all.
Yeah, no kidding. So that's beer money right there. So we've got the flare. We made a perfect flare. We use your top of the line tool because let's get the top of the line stuff and make our life easy. So then we got the flare nut on there, and then you tighten it, and it's as tight as you can get it, then plus a 1/4 turn, and then you back it off a 1/4 turn. Right, that's the way we tighten.
Sounds like
right?
a leak, Paul.
Yeah, I know. That's how we do it.
That sounds like the same guy who gave you the nickel or the dime analogy, right? Yeah,
no, exactly.
So we want to make sure that we're using a torque wrench and digital if possible in the name of precision. And then, on top of that, one that we want to make sure that if it's using, say in our case, an adjustable head, that's kind of a lesser of two evils in our mind, because the advantage is not having a bag full of flare heads, dedicated size flare heads. Those have a superior grab on a flare nut. The downside is the bulk and carrying all that. So, the other side is you get an adjustable head like ours. The downside to that, of course, is we know that an adjustable wrench has a little bit of slop in it, has a little bit of play in it. So you want to have if you're going to do that, if you're going to have a digital wrench, you want one that can compensate for that. And that's built into the logic or the sensor, that's the wrong term, the electronics. Okay. I'm not the engineer, but it's built in, it's factored in, that amount of play, is accommodated for. And then once that's done, it really is superior design to be able to have the single adjustable head. We do, after listening to the community, had needed to come out with another optional add-on head for some manufacturers that have a much wider flare nut. So, flare nuts aren't all the same. They may be for the same size flare, but the thickness and the wall size of the flare nut is a lot different. So we did go ahead and we added that as an option for those individuals that need that.
Right. And
what's nice about the head, the adjustable head, is we have it removable. And that's not just to swap to the larger size. That's also so you could flip it around. So if you're up in a ceiling, the handle's probably about, if I'm just guessing here, say it's 13, 14 inches.
Yep.
you may need to flip that head around so that you're, hopefully everybody knows that, a wrench, it's oriented it needs to be oriented in a certain direction for when you're tightening. Right. So for you to be able to do that in all conditions, all scenarios, whether it's pretty tight in there, you can do that.
Yeah. I'm going to tell you, when I first saw the adjustable head, I'm thinking to myself, I'm not sure. But then I started thinking about it. Give an apprentice a socket set. Let's just say there's 20 socket sizes in there. He'll have that in there the day you give it to him. But a year later, he's going to have 3 or 4 of them missing. And the same thing's going to be. If I have 10 different heads to go on this wrench, in a couple of years, I'm going to be missing 1 or 2. And then I'm stuck anyway. So I actually like the adjustable head. If I just got 2 of them, I'm going to keep both of them. So that's important.
Let's face it. You'll see the quality in that manufacturers put into good adjustable wrenches. There's little slop, as Andrew said. Yeah. And then you have just the cheaper adjustable wrenches, and you're going to lose knuckles with those and stuff. So if they're putting in that quality into that adjustable wrench, that's going to be
But there's something, Andrew, there's something that you said that I don't think a lot of people realize. There is a wrong way to put a wrench on. There's a way to turn it backwards. You got it on backwards, and it's designed to turn a certain direction in one direction only. Right. If you're going to turn it the other direction, you got to flip that around. I don't think a lot of people realize that. Yeah. I know my son doesn't. Yeah. What are you doing?
And with a pipe wrench, it's really important.
Yeah.
and I know that there's some people listening right now and saying, this guy's full of crap. He just said that the head is reversible. Why am I not just flipping the whole wrench around? Why aren't I just spinning it?
It's a torque.
They're right. You can do that, and then you're oriented right. But at that point, remember, there's a digital wrench, so there's an interface. There's a screen with LEDs that run up as you're approaching your program torque spec. I forgot to mention that. So that is why we have the head reversible. Versus just turning the whole tool around, because then you're now not facing. We want to be able to keep that screen facing us. In a tight environment. So I just want to make that clarification.
Yep. Oh, I get that. All right. So we got the flare nut made properly. We got it tightened up properly with the right torque settings. Bryn, where do we get those torque settings?
Your install manual, of course.
Install manual has the torque settings, and it's based on the size of
your pipe.
The pipe.
Yeah.
Is it the size of the pipe or the size of the flare nut it's based on?
The size of your pipe.
The size of the pipe.
Yep.
Because some flare nuts, as Andrew mentioned, are thicker than others.
Right. And you should be using the flare nuts that come with our equipment. Right. You don't want to discard those and just grab any old flare nut out of your truck from 1982. Not a good idea. Our flare nut's a little bit thicker. Like Andrew was saying, you got some flare nuts are a little meatier, and that's ours.
All right, so earlier you talked about evacuation. Right, so what kind of tools do you have to help the contractor do a proper evacuation?
Okay, so again, with evacuation, this is our bread and butter. This is our real claim to fame here. So we have more solutions for more applications in evacuation than anybody combined. And I don't say that haphazardly. We truly are able to accommodate any technician, whether they're working on a PTAC unit in a Motel 6, all the way up to a centrifugal chiller in a cooling plant, and everything in between. We have everything from a 2 CFM to a 300 CFM vacuum pump. Clearly 300 CFM, well outside the HVAC application and HVAC world. It's just going to show, though, the capabilities that we have on a manufacturing level. And, as such, we pay a lot of attention to application because we have the means to really cater to a precise application. So, yes, the vacuum size, the vacuum, the CFM rating, that's all good and well. However, as hopefully more people have come to learn over the last, 5-8 years, we have to level the playing field first. And that's by making sure that everything between that pump and the equipment is enabling that pump to perform as built. And many of the times that's not the case. So, to summarize that into just a few, key points, it's removing all restrictions. It's maximizing the diameter of what we're evacuating through, and it's minimizing the length of that tubing, right, or hose. And with our vacuum solutions, all can be achieved.
I saw one of your, I saw Ty Branneman. Is that his name? I'm going to get the name wrong.
Yep.
I saw a YouTube video with Ty. He actually put a 4 CFM battery operated vacuum pump on a 55-gallon drum. And we got to get him on here because he explained why this happened. And I didn't think it would ever happen, but this drum imploded. And I was shocked. And the way he explained, I'm getting off topic here, but the way he explained why it imploded like that and why refrigerant piping doesn't implode made a lot of sense scientifically. But I was shocked that a little 4 CFM, and people think, oh, the bigger the better. But when you're evacuating, too big of a vacuum pump is actually bad. So I like 4 CFM. I think the one I carried was either a 6 or a 7 CFM. But
so too big of a pump can be bad. What I would push back a little bit on though is why. I think more often people have the narrative that too big of a pump, is more of a problem because of freezing potential with moisture, freezing moisture in the system. Whereas in my opinion, the bigger downside to an oversized pump is that the technician has maybe spent too much money on their pump when they didn't need to. So the reality is, there's many videos on YouTube that show this phenomenon of being able to freeze water in a vacuum, right? Boil water in a vacuum, at a much lower temperature, right, than what we're accustomed to, and then also being able to freeze moisture. However, I would challenge anybody to show me one of those videos where the demo vessel isn't a glass jar of some kind, right? Which is great for the demo because you can see. But what people need to remember is that glass is one of our best, one of the best insulators that you can come across. So, this is a situation where, a lot of stars have to align. You need to have a greatly oversized pump, compared to the vessel you're evacuating. And you need to have little to no heat stored in that vessel, right? So when we look at an HVAC system, people don't think of the tubing as anything other than tubing, but it is the vessel, right? And copper is the complete opposite, right, of an insulator. It's one of the most conductive materials on the planet, outside of, I think, copper and silver, which we clearly won't make line sets out of, right? So copper's about as good as it gets. And even if you're in the just outside the Arctic Circle, you're gonna have actually a decent amount of heat energy in that tubing. You won't feel it with your hand, but it's there. And you really have to have a situation where, one, again, the pump is greatly oversized. Two, that tubing has truly frozen. I mean, it's about as low a temperature as can be, below freezing. And three, standing water in your system. You need to have pretty much poured water in a water bottle down into the tubing. Yeah, and that's what that's just not really a reality in the field. So that can be. So I guess what my point is that it's never. It's not just the pump. People also use this as a reason not to use large hoses. And what I tell them is that this scenario of freezing moisture because your hoses are too big or you pulled the Schrader cords out, it's not even remotely an excuse to not do things the right way. If you really want to mitigate that, use a properly sized pump with your large hoses. And if you really need to, if you're really somewhere that you had some water in there, moisture, rain, and you're in the middle of winter somewhere way up north, then take a heat gun, take some kind of heat source, heat up that compressor, run the blower inside, keep a heat load on the coil. You're going to be fine.
Yep. I've got a video I'm going to send you. You might already have it. It was sent to me by Ralph's former coworker, Paul Hale. And it's one of our units. The guy was pulling a vacuum on it, and then he opened it up, and out of these pipes comes ice, and it starts boiling off immediately. And there's no other way to explain it other than there was standing water in the system.
Yeah.
There's no way that can happen unless it was open to the elements, maybe when it was roughed in, like I said, but they didn't cap it off. But
Right.
it's something other than that video, I haven't seen it personally, but I'm a big fan of getting the right pump. I'm a big fan of a triple evacuation, and not so much because of the freezing water, but
And we
just
can't see it. We can't see
because
inside the pipes.
you can't see it.
we
but,
just, we know science and what it's supposed to do. But Andrew brings up a great point. What I wanted to ask, Andrew, is do all your vacuum pumps have a gas ballast?
Good question.
So every pump from NAVAC has a gas ballast except our absolute smallest pump, which is that little baby 2 CFM vacuum pump. And that's just purely because of the manufacturing limitations with a pump that small. It just didn't work to get it in there. So,
and the reason I bring this up is because I think probably 55% of the people in our trade don't know what the heck a gas ballast valve is. They probably never used one. If it's been on, can you explain what the purpose of the gas ballast is on a vacuum pump? Why are we using that?
Absolutely. So, again, in keeping this as unscientific as possible and just easy to kind of grasp in an audio format, if you think of an air compressor, and you think of what's at the bottom of every air compressor that you would have, and it's a bleed valve, and that's for water, which demonstrates this idea that when air is compressed, the water, kind of like a sponge, it's going to get squeezed right out. It's going to be condensed right out of that air. It's going to fall to the bottom of that vessel. So when we think of a vacuum pump, and we have a system that we're just beginning to evacuate, within a few, minutes, typically the majority of water vapor, any moisture in that system, is moved out. And so it's a critical time to protect our oil. And so what a gas ballast does, and you're right, a lot of people don't know. A lot of people think it's to help you take your hoses off when you're done. And that's true. It does work. It does break the vacuum in the vacuum. It makes it easier to unthread your hoses. And then some people just know that, hey, I just open it when I start, and when I hear a change in the pitch, I close it. And that's okay. But it's just not the most efficient way of using it, because there is a point where there's diminishing returns and you're just actually kind of prolonging your evacuation. But here's what we want to remember. The most moisture is going to be in the first few minutes. It's going to be, laden in that air the atmosphere in the tubing. And remember, HVAC pumps are 2-stage. So we're running through the inlet of one rotary vane pump. It's being discharged right into the inlet of another. And when we're doing that, we're in some ways compressing that air. And if we have that most moisture-laden air right in the first few minutes, there's a good chance, much like the air compressor, that we're going to have that moisture condensed and fall right into the crankcase of our pump. It's going to immediately pollute the oil right at the onset of the job. And that oil, the integrity of that oil needs to be maintained, or a rotary vane style pump will not pull down to a low micron level, because the oil is what seals between those veins and the chamber that they rotate through. So that gas ballast in an unscientific way is breaking. It's almost handicapping that pump's full ability to run at full, two stages, in order to guide that moisture out and keep it in vapor format. And that sweet spot that we teach people is, and it's not a perfect range, but it's the most efficient window, and it's easy to remember: 20,000 to 2,000. 20,000. So when you start reading microns, usually many micron gauges, including ours, they don't really start giving you a readout till about 25,000. If you're opening it before that, you're not really, you're not hurting anything, but you're not really helping either. And then if you're going much below 1,500, 1,000, you're starting to get into that range where you've probably removed all the moisture at that point.
Yep.
And now you're just kind of delaying the degassing part, because remember, we're dehydrating and degassing the tubing and the coils. So once we've removed that moisture, the dehydrating portion, we still need to remove any non-condensables. And with that ballast open, you're not going to really do that well. You'll never get below 500 in most situations.
Right.
So at around that 2000 mark, that's where I'm going to go ahead and tighten it back down. That's kind of that went a little longer than I thought.
Andrew, I love that explanation. That's perfect. I think for our listeners and everybody that probably didn't know what that gas ballast did, and if they have a really old vacuum pump where it's just beat up, and like the ones that I used to use, they just had that little brass turn screw and probably just stayed slammed shut. No one ever used it.
Oh, yeah.
But that's awesome. Let's move to recovery machines and your line of recovery tools. And at the same time, let's talk about what's going to have, what do you have for tools for A2L?
Okay, so big question, several elements to that to answer. Now, with recovery, again, it's another category we're very proud of. I don't know if you'd have any other tool companies out there that have the range of machines for the different range of applications and budgets. So I believe we're the only manufacturer to have at least 3 machines in different budget territories and applications. They are all what I would call A2L compatible, and then we have a 4th that is actually A3 compatible. And we have machines that are perfect and ideal for residential applications and light commercial. We have a kind of what you'd call a Cadillac version of that machine, but for that same application, just with some more added features and conveniences. And then we have another machine that's, to my knowledge, unrivaled in the industry. I don't know of, and it fills a gap where I didn't mention this, but prior to NAVAC, I came from Johnson Controls, and I was a chiller mechanic, HVAC technician for them. And when you recovered some of these large chillers, you're in another world at this point. And the machines that we're using, they're humongous. Sometimes they're Frankenstein to get. Sometimes they're homemade, using old large receivers, and you've got water coils on them, and they're water cooled. They have belt driven motors on them. There's all, and now you're in just a complete different price range at that point, and you're never going to see that at a distributor. So you're also not going to want to use your typical residential style recovery machine for these systems. Right. So what we did is we created a machine that is portable. It's it's something you could put back in your van every day. It doesn't have to live on site, and it is perfectly suited for both chillers and large VRF systems. So in the case of the City Multi products, definitely the biggest of those jobs, that's where a machine like this would shine. And it's actually a dual compressor. So it's 2 compressors, 4 cylinders, 3 fans on this machine, with push-pull features and abilities, as well as vapor recovery. So all of our machines, they've got microchannel coils, DC compressors, among many other features that allow them to work properly for their environment, but also with new refrigerants in mind.
Awesome. So so your whole line is basically brushless tools for A2L.
Yes, and in our eyes, that's a big. That's not 100% of the time, but in many cases, that's a big part of what makes us very comfortable promoting these tools in those environments. Yes, there are AC. We have a couple AC driven products that are compatible with A2L refrigerants. And contrary to some sales reps in the field or manufacturers that are saying otherwise, it's just not the case. An AC motor can be built in a way that's enclosed and keeps that potential arcing from exposure to refrigerant. So, but yes, in most cases, in many cases, a DC motor is just the it's the lighter option, it's the quieter option. So many times that's what we include.
Excellent. So I'd just like to finish off with any smaller NAVAC hand tools that you have. So we know you have the pipe prep tools like the reamers. What else do you guys offer?
Well, smaller tools and other tools to keep in mind, leak detectors, manifolds, these types of things are probably among the tools that I would say, at some point maybe look to upgrade if you need to, or keep the A2L concept in mind. Vacuum pump, recovery machine, leak detector and manifolds. However, I think a lot of the A2L topic has been overhyped on the tools. Yes. On the tool side. There's a lot of fear mongering, and it's just not necessary. As working for a tool manufacturer, I guess in some ways it could help for me to jump on that bandwagon. But I think long term, it's better to be honest about the conversation. And there was far more to be worried about with the transition from 22 to 410.
Agreed.
Than there is from 410 to 454B or R32. And there's another thing to keep in mind when we're saying A2L compatible, A2L rated, which I stay away from that term. That's marketing fluff. Okay, there is no governing body at this point. There will be, I'm sure, but at this point, there is no standard with a safety organization that truly certifies something as specifically A2L refrigerant a certification or compatibility. So what we can do as a manufacturer, anybody can right now just slap that on their box, unfortunately, and it's happening. But what we try to do is look ahead to what the future would likely mandate. We kind of put our safety organization hat on and look forward and say, well, what would, something with a slightly flammable environment need to be as safe as possible? And that is going to be, the inclusion of DC motors when available, the inclusion of a fan, if it's something like a recovery machine or a vacuum pump, brushless when we're talking about hand tools, that are, power and could have the potential for an arc, and just things like soft contact power switches that are using, solid state, relays to, turn a tool on instead of just a hard switch that could have some kind of an arc. These are the things to keep in mind, but a lot of people are conflating or mixing up A2L with the safety side with the convenience side, and we've tried to do both. So when somebody's saying that their leak detector is A2L leak detector, did they necessarily design a whole new leak detector? Probably not. When you think of A2L compatibility, are we talking about a leak detector's safety with A2L refrigerant, or are we talking about its ability to sniff out A2L refrigerant? Right. To me, they're both important, and it's most likely that your leak detector now is fine in that sense. It's 410 has what's the percentage of R32 in it, right? And that's probably a big part of how it was sniffing out 410. So it's very likely that you're okay from that standpoint. And to my knowledge, all the leak detectors out there are battery operated, so they're not going to be much of an issue in terms of creating arcs. And then the ones with heated diode, how hot are the heated diodes really getting? Are they in a situation where they're going to interfere with that lower flammability limit or that ignition number for R32 and 454B? So again, I think, it's a really vague term that's being thrown around, and we just got to keep in mind as technicians, change over your tools when you're ready. You don't need to throw everything out now. Most likely the tools that are having A2L thrown on the box, they're in many times referring to the convenience, right? So with our manifolds, we have a new line of we have 2 or 3 new SKUs of analog gauges, for example, that we're calling our A2L manifolds. There's nothing about them design-wise that makes them safer with R32 or 454B or what. It just means we've put the R32 scales on the dial.
Yeah.
Sure.
Right. I mean, that's it. So in that sense, it's a convenience. So instead of having to pull out a PT chart or look at your an app on your phone. So, does everyone have to go chuck their gauges tomorrow and get A2L gauges? Absolutely not.
Not as long as you
when the
have a PT
time
chart,
comes
then.
and you bust them, or you're ready to upgrade. Well, maybe look for a set that's got those common A2L refrigerants already on the scale, things like that. So I just want to kind of clear the air on some of that stuff, that this is not a doom and gloom scenario where people need to completely overhaul their vans.
No, I've been saying that for months, exactly what you said, that going from 22 to 14A was a much bigger deal, simply because of the pressure difference in the two. That was the big thing, was scaring everybody. And then the same thing happened then. We were told you can't top off 410A because it's a blend, and guess what? Yes, you can. And the same thing is true with 454B. You can top it off. If you got a leak and you lost a portion of that charge, you don't have to recover it all and start over. You can top it off. Now, it's important to find the leak eventually, but if it's Friday afternoon at 4 o'clock and you need to get going, top it off and come back another time and find and repair that leak. But
sure,
I want to get back to the manifold, because there's something unique about the new recovery tanks.
Yeah, absolutely. And thanks for guiding me towards that, because I completely forgot. So when we're talking about bits and pieces and hardware and fittings, we had to look ahead, and we're kind of at the bottom of the totem pole, right, on changes in the industry relative to refrigerant. So, the EPA kind of is at the top. They're starting all this, then that kind of trickles down to the agencies and the HVAC safety industries, and then from there, and in conjunction with the equipment manufacturers, decisions have to be made. Are we overhauling equipment? Are we, making running changes to equipment? What is going to be included on the equipment from the manufacturing plant versus, added in the field by technician, field added, if we're talking about, mitigation, safety and mitigation strategies for the equipment. And then after that, the tools have to respond, and the tools have to be able to match the technological upgrades and the demands that make those installs proper and efficient. So what we know now, what we've heard, is that there's manufacturers that are, potentially at some point going to have reverse threaded service valves. We've also heard that recovery cylinders will have reverse threads, and that the virgin tanks. So, in the case of R32, 454B, they'll have counterclockwise threads. So as such, we did, I think along with most others, we quickly came out with adapters that would allow people to adapt their current hose setups. And I think that we are the only one to have also come out with a dedicated hose. So we also have a purpose-built hose. It's orange in color. Yes, it's the NAVAC colors. That's part of it. And it's also, what we're calling our line of recovery hoses. So we have a whole line of recovery hoses now too that are orange to help technicians distinguish and keep that separate from their evacuation hoses. But one of those is the A2L purpose-built hose. So it comes standard with one end standard thread, the other reverse. So it can park on the outlet of the recovery machine, and then it can run to a reverse threaded cylinder. And then we also have the adapter to be able to go, from a manifold, say, to the equipment or to a virgin tank in the case of charging.
Yeah.
Cool.
Yep. Excellent. This is great. Andrew, can you let the listeners know where they can find NAVAC on the internet and any other resources that you have, training, podcasts, or anything?
Yeah, absolutely. So a great starting point would be navacglobal.com. And from there, we have many resources. We have, I believe, a link tree as well on the website. But under the resources tab, I mean, we've got access to, product data, product materials. We have a distributor map so that technicians can find the closest participating distributor partner with NAVAC that carries NAVAC, so they'll be able to source the products. Yes, we are also in participation with several online distributors. And from the website, you also have access to, the training resources. Yes. So in your area, we would say if you do have a distributor that you are, loyal to, and that to make that known that you'd love to have some NAVAC training, and if the seats can get filled and that distributor wants to reach out, they can, of course, always reach out to us at training@navacglobal.com. That goes to our training department. The specific questions can be asked, and we do have a great curriculum available for evacuation, for recovery, for tubing practices, and then also for the A2L low GWP familiarization. And that training is actually collaboratively put together with the ESCO group. So there are members of the ESCO group that are actually on the SNAP boards, which are the basically in direct communication with the EPA. So they're kind of at the forefront. Well, they are at the forefront of these changes in real time, and as such, that ensures that our training, which has their name on it as well as ours, has that information as well. And our entire training department, including myself, are ESCO and NATE proctors as well. So we are allowed to, with our A2L class, for example, proctor the ESCO exam afterward for those that would like, the ESCO certificate for A2L low GWP training.
Excellent. Andrew, this has been awesome, and we'd love to have you back on, especially next year when we're swimming in that A2L change, right? And have you back on and talk about tools and talk about HVAC in general. This is awesome.
I'm going to come back and talk about food, but yeah, it's been a pleasure, and I really appreciate y'all having me on.
All right. Yeah. So I want to go back to the sous vide. Right, so you must have a vacuum sealer, right? So you said you like just sea salt on your steak, and sometimes that's all I want on my steak too, just coarse sea salt. So are you putting that in the bag with the steak before you seal it? And my second question is, does any of the liquid render out of this steak? And if so, what are you doing with it, or if it's in the bag with the steak when you're done cooking?
That's a great question. I've done both in terms of, salt before, salt after. And I don't know that I've noticed a big difference in the end result, but I prefer to salt it right before it hits the heat. So like for the sear. So I vacuum seal my steak, and I don't do any of the butter stuff either that I mentioned earlier. So for me, I'm just vacuum sealing beef. That's it. And when I'm done and I cut it open and I'm getting ready to go, I'm drying it off with a paper towel. I also don't subscribe to any kind of oil on the meat beforehand. You really don't need, if your grill is hot enough, which I understand a gas grill is not going to probably do it. Just to get it out there right now, for those of you listening, you may need to use some kind of an oil or something like that in that case. But if you can get your cooker hot enough, you don't need anything except meat and salt. And I do like to add it right before I throw it on. As far as liquid rendering out, yes, there is some liquid in the bag. It makes no difference losing that. in the final result. So again, your flavor is going to come from the marbling. The little bit of juice that's coming out is, the name escapes me of what it is. It's not blood. A lot of people think it's blood. It's not.
Fat.
Collagen.
Hemoglobin, yeah, hemoglobin. It's not pure blood or anything like that. And a little bit of hemoglobin lost is no problem. If you think of dry aged steaks and things like that, those juices, that's not what's giving you that great flavor experience at the end. So yes, you're going to have some liquid, but you know what? I'm going to be drying. I'm taking paper towels anyway.
Yeah.
You want to have the driest surface possible when it hits the cast iron. In my case, that's another thing for people to know, is that it is not necessary to keep that steak out to room temp. If you are somebody that's just going to grill steaks out of the fridge, forget the sous vide. We're just talking about regular, grilling of steaks, which is what I do too. If I have an inch or less, smaller steaks, I'm just going to have them in the fridge. And honestly, a cold surface, in my opinion, is actually better end result. You have a drier surface, and I salt it right then, and it goes right on the grill with fantastic results.
Mm-hmm. Yeah.
Bringing it up to room temp is going to get it all wet. And again, a wet steak is going to steam itself. You're not going to get a crust. Yeah. So if you're looking for a good sear and crust on the meat, which is called the Maillard effect, again, people think it's burnt. It's not burnt. It's a chemical effect with the surface of the meat and the heat. But what enables that is the moisture level on the surface, and it needs to be almost none.
Yep.
Yeah.
Nice.
And I can get my Weber kettle pretty hot. Paul, you can get your Weber slate pretty hot.
Yep.
So I think.
Oh yeah, Weber's good.
Yeah.
Weber's good for that. Yeah.
Yeah, we can definitely try this. I'll have to try it. Paul, you have to try it. And
I'm going to have to try it.
Share our results.
Yeah, we'll have to try it. But thanks, Andrew. Just one more thing, totally unrelated. Your website is NAVAC Global. Did you know that the Flat Earth Society has a global headquarters? I just thought I'd throw that out there.
Look, if you want to do another podcast, and I'm not a flat earther, but one of my favorite pastimes is going down the rabbit holes of if it's a conspiracy theory, I love to go down those rabbit holes online and purely for entertainment purposes. But
we'll say that for the next episode. Flat Earth. We didn't land on the moon. We'll go through all of that. Maybe we'll get Joe Rogan on here as well.
If the Earth was flat, cats would have knocked everything off of it already.
That's right.
True. Very true. Yeah. Even the sous vide.
Yeah.
All right. We'll see you guys on the next one. Thank you.
Take care.
Thanks, guys.
Later.